The students who have connected online, am I audible? So last class we were discussing about work object, right? I think the discussion is not yet completed. We need to extend that. So about work object continuation. Work object, class and table mapping. This one. So am I audible? Someone please unmute and confirm.
Yes.
Okay. So do you have any doubts about work object, PZPV stream, PYID, and PX create datetime? These things we have discussed. Do you have any doubts about those? So do you understand what is PYID column? What is PYID column?
The column which holds the case ID.
The column which holds work object ID. Okay. Then what is PZPV stream column? What is PZPV stream?
The details of that a particular record.
Work object details. In the transaction, whatever the data we enter, that will be stored into PZPV stream column. What is the format of data?
Blob.
Binary large objects. Blob format. Binary large objects format. That's the format of data in PZPV stream. Okay. And work object creation, date time, update date time, created operator, updated operator. These details will get stored into respective columns. What are those columns?
PX create date. PX create operator.
PX create. PX create operator. PX create date time, PX create operator, PX update date time, PX update operator. These things you would regularly use in the real world. Okay, you need to know about all of these things very well. Okay, and here you go now. So last class we were discussing about work object, right? Let's continue with that work object to understand about work object class and table mapping. Okay, let's go to our application. What is our application name? HDFC. Okay, so here you go now. Yes. So here you go now. We have a flow which is available in the work class, implementation work class. Okay, meanwhile, I'll also open the database. Today, I will share a document that has the steps related to connecting to database. Okay. So once you go to database, you will reach out to the respective database and schema and tables. So our table is PC underscore HDFC vehicle something. Okay, if you open this, you will see the work objects created are available here. Now, this is the flow. Flow is available in which class? Work class. If I execute the flow, then it is going to create a work object. The flow is going to create one work object. So this work object is created by executing a flow, which is in the class implementation work class. So in the context of implementation work class, you have created one work object. Okay, otherwise one work object is being created. Now for this work object, this work class is said to be instance class. What is it said to be? Instance class. Okay, so I'll tell you what is that word instance means. Okay, so work object is instance. It is called as instance. Every work object that we create is called as instance. Generally, instance means occurrence. Instance means what? Occurrence. Work object is instance of work class, or you say class group. What is that? Class group. Work object is instance of class group. So there is a word called instantiation. What is the word? Instantiation. Instantiation. Instantiation meaning that creation. Instantiation meaning that creation. There's a word called instantiate. Instantiate means create. Instantiate means create. We instantiate, okay, we instantiate one instance. One instance. Instance means occurrence. Instance means what? Occurrence. Something that has happened. Occurring means something happening. So work object means what is happening? A transaction is initiated. A transaction is initiated. So instantiation means you are going to do create something. I mean a creation. Instantiate means create. I think this is okay. Instantiation means I'll write down like this. Initiation. Otherwise, in another way, initiation. You initiate something that's called instantiation. As part of initiation, you will get something created. Okay, that is called instance. That is called instance. So what did we initiate here? By executing a flow, we initiated a transaction. So where is your flow? In the implementation work class. When you initiate a transaction, then a work object is created. So created means instantiated. So what is instantiated? Work object. Work object can also be called as instance. Can also be called as instance of what? Instance of what is the class in which it is created? What is the class in which it is created? Implementation work class. This is instance of implementation work class. Suppose, for example, I will go to framework work class. Generally, this usually is not going to happen in real world, but I just wanted to show you. This is also class group. This is also class group. I'll explain you technically what is a class group. It's work class. Class group means work class. Create, process. I'm going to create one flow in the framework work class also. Test flow. What is that? Test flow in the framework work class. So there is a flow created in the framework work class, which is also a transaction class. Actually, in real time, we will never initiate transactions in framework, even though provision is there. We'll implement only in the implementation always. Okay. And here I can call the flow action, which is available in some other class. I'm calling, let's say, send correspondence, one flow action. I don't know what is this flow action. Just like that, I've called, this is one OOTB flow action. Okay. And I'm going to turn off the draft mode, process tab, creates a new work object and skip create harness. Sorry, that is what PY case management default to create that particular initial screen. Okay. To skip that particular initial screen. Okay. I'm going to run this flow. So when I run this flow, then it is going to create one work object. Now this work object is created. Okay. This work object is created. Okay. This is created by executing a flow which is in framework work class, Now this work object C-10011 is set to be instance of framework work class. These work objects are instances of the previously created are instances of implementation work class because those work objects are created by executing the flow of implementation work class. Every one of you, are you clear with this point? Everyone. Online students, are you clear?
Yes.
Okay. So now let me open one diagram. So now in which tables these work objects are getting stored? Let's verify. Yesterday we have seen. This is one table. Okay. PC underscore HDFC vehicle work. So our work objects which we have created just now, 1009, 10, 11. Let's see if those work objects are available in this table. So 1009 is there, 10010 is there, but 11 is not there in the same table. Then where is 11? You go to another table, PC underscore HDFC FW HDFC INSU work. view data, first 100 rows, and you see the 11th work object is stored into a different table. What is the reason? Now you go to here once again, open the flow which is in framework work class, create one more work object by number 12. So this work object is also available and stored into a table which is a different table than the previous one, which is a different table than the previous one. Now look at here. Now I'm going to open one diagram. Okay, I'll open this diagram. Look at here now. Paint, and here you go now. See, this one, whatever you see here, this is your implementation work class. Name can be different, but format will be same. Implementation work class. This is framework work class, this one. And when you execute a flow, which is in implementation work class, you got a work object created by number C-1. When you execute a flow, which is in framework work class, you got a work object created by with a number C-2. Okay. Now, where is this C-1 getting stored? It is getting stored into some table by name. Let's say, for example, table 1. Table 1 or table A. Table A. And this one is table B. Table B. Why these two work objects are not storing into same table? How Pega recognizes the exact table where to store the work object? For that, I am going to explain you this. See, every transaction class, or you say class group, every class group in Pega is going to get mapped, to one table in the backend. Means there is a connectivity established between a class group, which is a concrete class, and one table. So class group and table are already linked. These are already linked. When this linking has happened, at the time when we execute the wizard to create a new application, correct? So at the time of creating new application, automatically class group got created. Yes or no? Automatically class group got created, right? So that class group at the time of creation, in the backend, one table automatically got created. At the time of creating new application only, the table to store the work objects is created. And there is a connectivity established between the classes and table. So for each class group, see, you created a framework application. For framework application, Pega has created one class group where you can execute the flow to make the transactions. In real world, we will never do that. Okay. In the framework class group, we will never do that. We will create reusable flows, but we never execute those flows. But in real world, we will create flows in the implementation. We will call the framework flows for reusability, and implementation also we do something, and we'll make a transactions only from the implement. That usually happens. But for Pega PRPC, an application is an application. Framework or implementation, it is an application. For every application, it will give one transaction class that we call as class group. There is a provision. You create a flow, execute the flow. It will initiate transaction, creates a work object, and the work object gets stored into a table. Which table? The table that is mapped. The table that is mapped to the class group where transaction is initiated. Understand this point, everyone clear? This is the fundamental architecture of Pega PRPC. Based on this point, your entire Pega PRPC will run. This is generic. Whatever I am telling you now, specific to work object. This is very generic for entire Pega rules process commander that you are going to understand in few minutes. So up to this, are you clear? Every one of you should respond on the chatting window. Everyone. Because without making this point clear, you can never understand Pega. Okay. Right? So now, how do you know from the front end of, how do I know exactly these are the two tables I need to go and verify for the work objects. So there are so many tables, right? How do I know? Once I go to the tables, there are around 3 to 400 tables are available, 372 tables. Out of 372 tables, how I am pretty much sure to verify only in these two tables. The reason is you also can come to know that how. This is implementation class group, correct? You go to the definition. Definition means details of a class group. Okay, details. Scroll down. There you see at the very bottom, class inheritance section, below that section, test connection is there. What is there? Test connection. What does it say? Test connection to the database table means you want to verify the connection between this particular class group and a table in Pega. Yes, I want to verify. I'll click on this. When I click on this, it will provide me information. It will provide me what? Information about the class group is mapped to a table. PC underscore. I'll just copy this to Notepad. Okay. What is the information I got? I'll copy this to Notepad so that you can see it. It will be pretty much legible here. Okay. So you can remove about these things. Okay. Now you see the class group. This is the class group is mapped to the table. Which table? PC underscore HDFC vehicle work. So it is giving you information of to which table it is mapped to, but where the mapping has happened, how the mapping is being done. So in order to map a concrete class with a table, Pega is going to make use of another rule in between. Another rule in between. Suppose there are two poles. If you want to connect to two poles, you need a rope. You need a rope. For connecting, something is required. Two entities are there, you need to connect. You need a rope to connect these two entities. I mean, like two poles. Same way, one entity here is class group. Another entity is a physical table in the back end. These two I want to connect. I need something else to be used. That is another rule. That is another rule type called rule type is database table rule type is used to map a class, a concrete class. Which class? Concrete class with a physical table in the backend, in the rule base. Backend means rule base. This point everyone clear? How do I know that? Now, where is that rule? Is that rule, should that rule be available now already created? It is already showing you the information. When you click on test connection, it is displaying the information that this particular class is mapped to so and so table, which means should that rule be already created available? Database table type of rule, should it be available or not? So it would have been available when it was being created while creating new applications. See, while creating new applications, so many things have happened in the backend. We don't know all those. First, we realized that when we create a new application, application gets created. Okay. Operator ID gets created. Organization gets created if not available. And then classes gets created. But now we are just digging inside and we were able to find out it has also created so many other things. A physical table created in the backend, connecting this class group with table, database table rule. I want to now see the rule which is already available. If I want to create, what I will do? Right click create. If I want to see a rule, then right click view. Right click view sysadmin database table. So what is the class group on which I have right click? That class group related database table rule type will be shown. So this is the rule created. Open the rule. When you open the rule, you will see HDFC vehicle work class is mapped to one physical table by name in the rule base by name PC underscore HDFC underscore HDFC vehicle underscore work. This is where mapping is defined. Understand clear everyone? To see the mapped rule, to see the mapping rule, okay. So right click on class group, thereby view sysadmin database table. Then it opens a rule. Then it opens a rule. Now, okay, it brings a rule. It browses a rule. Browses a rule. Then we can open the rule. Now, open that rule. Open that rule. So you'll find the information. Now open that rule. You will find the information. Understand clear? In the same manner, if I want to know what is the physical table in the rule base for which framework application class group is mapped to. So I want to know framework class group. This class group is mapped to which rule I want to know. Can you guys tell me the navigation now? Right click on framework class group, view, sysadmin, database table. View sysadmin, database table. Open this. Then you will get the instance. Open this. You see now table. So this table should exist in the backend. So first Pega will create physical table. Here it will create class group. Okay. Then it will create database table type of rule to map the class group with table. Suppose if the table is not available in the backend, if I type some name here, the table is not there in the backend. What will happen? Connection will be done. Connection will not be done. So why do you, when would you come to this place? When would you come to this particular place? You would come to this place only when you want to modify this table name. If you just wanted to know, what is the table for which this class group is mapped to, you don't have to go to database table rule. You can go to definition of the class group, click on test connection, you'll come to know what is there. When you would have to go to database table rule and open it, if you need any modifications to be done, then only you go there, otherwise no need to go. Understand? Let's take an example. There is an example. There is a table by name PC underscore CEP underscore events underscore repository. Just one table is there in the back. Now, if I go to right click on this, view sysadmin database table. Okay, and open it. And if I change this name with an existing table in the rule base already there, let's say for example, table A. Imagine table A is with a table by name table A is already there in the backend with all the required columns. Suppose if I save this and then after saving, if I create work objects in framework class group, into which table these work objects of framework class group will get stored then? Into table A. Suppose in real time, if you get a business requirement, the requirement is like business says, when we create work objects of framework, okay, implementation, some class group, it is getting, those objects are getting stored into table A, for example. Now, business do not want the objects to be stored into table A. They have created another new table by name table B. Now they are informing the developers. They're giving a requirement to developers. At present, this particular class group is storing it. This particular class group work objects are storing into table A. So we created a new table, table B. Please make changes in the development tool in such a way that the objects further should store into table B instead of table A. What would you do now? How do you implement this? Change the table name where? In the database. So you'll right click on that particular class group, go to view sysadmin database table, open the database table rule, then you are going to change the name of the table there. Then it will store into a new table. Understand clear everyone? Online students, are you clear?
Yeah. How do the structure matters, Harsha, here?
Structure doesn't matter at all. Never bother about structure. It doesn't matter at all. Okay.
Okay.
That is some convention Pega will follow. Structure doesn't matter at all. I did not make any changes, right? Table here, nothing. Okay. I just showed. Okay. Structure and table names doesn't matter. Name can be anything. Structure can be anything. Okay. Now let's go to one abstract class. Let's go to one abstract class. Now right click on the abstract class definition. Do you have any option here in the abstract class? Test connection to table. No option is available. Why?
We are not initiating any transaction
We are
here.
not
We don't need to store anything.
Cannot initiate any transaction. Abstract classes doesn't have instances. Abstract, when instance is there, you need a storage. Instance itself is not there. You don't need any storage. You don't need any storage. Okay, clear everyone? So you need a storage only when instances are there. Abstract classes will not be having any instances. You cannot initiate transaction in the abstract classes. That's the reason why you cannot store anything. You don't need to store anything. So you don't need any table also. That's why you do not see anything there. So if you right click on abstract class, view, sysadmin, database table. Where is it? Somewhere, sysadmin, database table. No, nothing is there. There is no table connectivity. There is no table first of all to connect. You cannot do it even. Okay, even the table is there, you cannot connect this. Okay, that's not correct. Okay, now here you go now. See, we'll come back to the point. Work object is instance of class group. So what does it mean? So the work object you create, the work object we create gets stored into a table which is mapped to its what? Class group, to its class group. Understand clear? So work objects will be written into table. Written means stored into table, which is mapped to the class group of that particular work object. Every work object is instance of respective class group. For a given class group, how many instances? Instances means work objects can be there. How many work object instances can be there? How many work objects can be there? N number. So if you go here and go to implementation class group, just to single click on this with left mouse, single click on this, it will show all the instances. These are all instances. So far we created these now. These are all instances of this particular class group. If you go to framework class group and click on this, these two are instances of framework class. Make sense clear? This is how you'll come to know. Online students, everyone following? So I'm trying to explain you the fundamental architecture, foundation of Pega PRPC. I'm trying to explain you the foundation of Pega PRPC. Okay. Now, what do you understand or learn based on this concept? You know this, how it is going to benefit you. Okay, let me explain you now. Here you go. So now can I give you the technical definition of work object? Work object is instance of class group, right? I'll give you definition of class group also before we proceed further. What is class group? This is what is work object. What is work object? If someone is going to ask you, you need to tell the technical definitions. You need to tell what? Technical definition. The same person is going to ask you, then what is class group? Tell me technical definition. Class group will have instances. Those are work objects. Class group is, it is a class or not? It's a class. Class group is a concrete class. Yes or no? Okay. Which derives from, derives means what? Inherits from OOTB class work dash. Ultimately, what is the OOTB main class? Work dash. Class group is a concrete class which derives from OOTB, which derives, instead of saying which derives, which must be deriving from, which must be deriving from OOTB class work dash, or its subclass is also work dash. Ultimately, work dash, which is means class group is instance class. What do you call it? Instance class. What do you call it? Which is instance class of what? Of work objects. Of what? Work objects. More than one object will be there, no? Class group is also a class. So you call it as instance class. Instance class of work object. Instance class of work object. So class group is a region where that is the birthplace of work objects. That is the birthplace of work objects. Suppose there is a person who born in Hyderabad location, Hyderabad region. His data will be stored into, okay, government department database which is mapped to Hyderabad region only, but not to Bangalore region. A person who born in Bangalore region, his data will be stored into government database, which is mapped to Bangalore region. Each region is having a database table mapped to it. So each class group will be mapped to some table. The work objects that are born in the region of class group are going to get stored into table which is mapped to that particular class group, which is mapped to that particular class. So these work objects in general terminology, we are calling them as instances. Why? These are getting instantiated, created. So that's why we call them as instance. Work object is instance of a class group. Class group definition. Class group is a concrete class, definitely, which must be deriving from the OOTB class work dash, which is instance class of one or more work objects. Okay. Clear, everyone? So I'll write down one generic point now. The instances of a concrete class. Okay, I'll write down one more point now. Only concrete class is going to have instances. Only concrete classes will have instances. But not abstract classes. Are you clear with this point? Every one of you online. Okay. The instances of concrete class gets stored into a table which is mapped to the class, by database table rule type. That is going to help in mapping. Understand clear, everyone? So let's proceed with this now. Now I will open one document which I have shared you the other day. I'm sorry. Here you go now. What is it? Pega classes, theory documents, hard copy. I have shared you this document when I explain you about properties, section, flow action, flow. I've shared one theory document. In the theory document, there was a point written. What was the point that was being written in the theory document is, at the very beginning, ignore reading red color statements for now. So this is a red color statement within property rule when I am explaining. Second rule type is section. When I am saying section, there is another statement similar to above one you found. So flow action also same. What are these statements? You know, these are the statements that I have written here. What statements I have written, you know. So property, this is how something I have written. Property, okay, this is from the document. From the document I brought it, okay? From the document. So what are the points I have written, you know, about property, about section. Section is an instance of concrete class, okay? Rule dash, HTML dash, section. Similarly, when I give you notes about flow action is an instance of class, is an instance of concrete class. Okay, what is that? Rule, OBJ, flow action. And flow, when I tell you notes about flow is an instance of concrete class. So similar points I have written for everything. Similar points I have written everywhere. What are the similar points? These points look similar, right? Rule, OBJ, flow. So when you read this type of statement in Pega, what do you understand? When you read this type of statements in Pega, what do you understand generally? So you need to understand one point, which is in this sense. The instances of concrete class get stored into a table which is mapped to that particular class by database table rule type. Now, property is instance of concrete class rule of the property, which means what you need to understand. So property, rule, and its details. It's a details. What are the details? Property name, type of the property, whether it has any local list of values, what control it holds. You open a property, you'll come to it. So you just go here, you just open one property here. So if I open a property, this is a rule in Pega. This rule has a name. This belongs to a class, and this is having one property type. This is having one control. This may have table list, table type, local list, and some values optionally, choices. So this is called metadata about the property. This is called metadata. Details about the property are going to get stored into the table. So property rule and its details are getting stored into a table, What is the table name? PR underscore rule underscore property. PR underscore rule underscore property into a table. And this table is mapped to the class. Which class, tell me? Rule obj property. This table is mapped to the class rule obj property. Understand? By reading this statement, you should get this realization. So from this, what you can understand, every rule we create in Pega definitely is a record in the table. In the back end, this is the record in the table. So if you go to Pega database, here we are in data schema. Where are we now? In the tables. These tables are available in data schema. If you minimize data schema, there is another schema called rules schema. So in Pega, data is separate, rules are separate schema. Schema means categorization in database concept. Now go to rules schema and scroll down. There are some number of tables. All these tables got created when you install Pega. Now PR4 underscore rule underscore property. Is there a table like that? Right click on this, view data, first 100 rows. So many records are there. Pega has so many OOTB properties. So suppose if you create one property in Pega environment, in any class, you create one property in Pega environment, that property details will get stored into this particular table. What Pega will do, whenever you click on the property to open it, based on this name, it will go to PR4 underscore rule underscore property table, matching record it will fetch, and it will show it in HTML format. It will show it in HTML means browser format. Okay, that we can understand in a browser. Every one of you clear? Everyone online, are you clear with this point? Now, the fundamental architecture of Pega you are going to understand. What is the primary fundamental architecture of Pega? Every rule that you create in Pega, every rule is definitely going to get stored into backend tables. All the different types of rules are going to get into same table? No. The rules of one type means property is one type, section is one type, flow action is one type, flow is one type. How many properties I can create? How many rules I can create of type property? N number. How many rules of type section I can create? N number. How many rules of type flow action I can create? N number. How many rules of type flow I can create? N number. So if you create some number of rules, one or more rules of a type, one specific type of rules get stored into one table. All properties get stored here. No? Similarly, section. Coming to section. So section rule will have a name and it will have some controls inside it. Controls mapped to properties. Layout is metadata. Section rule and its details are getting stored into a table. I'm sorry, I have to write PR4. PR4 underscore rule underscore. I'm sorry, where is it? PR4 underscore rule underscore section. This table is mapped to the class. Which class? Rule HTML section. Rule HTML section. Understand clear? So can any one of you tell me now, what about this one? The next one. So can you tell me now, next one, online students. For this one, if I write the similar statement, tell me. You need to respond. Online students, you have to respond. Don't sit there simply.
PR4 flow action, rule flow action.
OBJ flow action.
Rule PR4 underscore rule underscore, let's say in a general naming format, flow action, which is connected to rule obj flow action. Rule obj Flow
Yeah.
action. Understand clear everyone? Similarly, this one also you can write now. Now, how do I know these things? Okay, because I have knowledge, I am explaining you. I have written already notes. Suppose there is a rule type for which you do not have this type of statement. How do you learn to find out? Okay, I'll tell you. Flow action, flow rule. Rule PR4 underscore rule underscore flow. Like this, I'm writing. Rule obj flow. Sometimes, Pega maintains a generic table for different rule types. That is also possible. Okay, but anyhow, every rule in Pega Pega is an instance. Every rule in Pega, you are creating a rule or not? You are creating means you are instantiating something in Pega. Every rule is an instance of a concrete. Every rule in Pega is an instance of a concrete class. That's how Pega is architecture. Concrete class. Now you see here, you just open a rule. I don't know about the instance class of this rule. Suppose, for example, how do you know the instance class of a rule? Open the rule, go to actions and view XML, view XML. Some data will be open. Control F, PX OBJ class, PX OBJ class. This is an OOTB element. So rule OBJ property. So if any rule you open, go to actions, view XML, then you do control F to find out PX OBJ class tag. Whatever the value is there for the tag, that is the instance class of the rule. Now you take that rule instance class, go here. Here you can find in the search, class search. So now you can see, right click on this class. I just wanted to know view or not definition. Definition, this is the concrete class or not? And test connection to table. It is mapped to PR4 underscore rule underscore property. Understand clear everyone? This you can repeat for every rule. To know, to learn, understand architecture. Make sense clear everyone? Online students, are you clear with the point?
Sir, but we have created the property rule in our abstract class,
Yes.
right?
Property rule you created in HDFC class, correct? But I'm talking about it is an instance of. What is HDFC class for the property? This is called rule class. This is called rule class, means the class in which you created the rule. See, in Pega, you can create properties in many classes. Okay, but anywhere you create in Pega environment, this property rules stores are instances of rule obj property only. But then what about the respective class in which you created? That is called rule class, shelter class. That is just a shelter class. Okay, that is not instance class. Make sense? So that's called rule class. Okay. Now, see, we have got 2 points. Work object is instance of class group, which is a concrete class, correct? Then rule is, now what is a rule? Definition. What is a rule in Pega? So someone is going to ask you this question in interview. What is a rule in Pega? Rule is an instance of a concrete class. Instance of a concrete class. So here work object is instance of class group. Rule is instance of some concrete class. Some concrete class. So from this point, is it okay if I say, see, work object is instance of class group. Work object is, every work object is one row in the table, which is mapped to class group. Similarly, rule is instance of some concrete class. So every rule you create is one row in table, which is mapped to the respective concrete class. From this, is it okay to say work object is a rule? Work object is instance of concrete class, of course. Yes or no? Work object is also instance of concrete class. So this is also instance of concrete class. Both are concrete class only. This is class group. This is not a class group actually. This is only concrete class. So from this, is it okay if we say work object is a rule? Can we say that like that? Work object also can we say as a rule?
Yes, by looking this statement, we can
Okay,
say.
so I'll write down, you can tell me now. Suppose, for example, human is an animal. Okay, and dog is an animal. Similar statement I'm writing. From this statement, is it okay if you say human is equal to dog? No, you should not say that, right? The same way, work object is data instance. What is that? Data. It's about data, transaction data. Rule is rule instance. Rule instance. This is not work object. Rule instance, data talks about the data in the transaction. This talk about a rule. Rule talks about rule instance. So that's what we have. In future, we will get this topic. In future. So that's additional information I have given you to give you the architecture of Pega. So the fundamental Pega PRPC architecture is like this only. Every rule that is available in Pega is a record in the table in the backend. Okay, every rule that is available is an instance of some concrete class which is getting stored into a table which is mapped to the concrete class respect to concrete. So Pega is all about rule base. Pega is all about. So whatever you see in Pega front end is reflection of backend. So that's why you call Pega rules process command. Why Pega rules process command? It's all about rules. Rules and stored into rule base. Rules are there in rule base. Pega PRPC environment is reflecting the rule base details. Now coming to the next one called debugging tools. What is that? Debugging tools. Next topic, debugging tools. So up to this, you have got a generic idea about Pega architecture. Okay. Debugging tools, Clipboard, Live UI, Tracer. Most importantly, now we will focus first on Clipboard. First one, Tracer after some time, not now. Okay. So Clipboard. So what is a Clipboard? Clipboard is a debugging tool. Clipboard is a debugging tool. So can you tell me, in your day-to-day life, you might have seen this word Clipboard somewhere. Where you have seen this? Clipboard you might have seen, no?
I'll copy.
Online.
Yeah, copying today.
While copying. See, on your Windows laptop or Mac laptop, anything. If you right click on a file and choose a command copy, then it will be copied. You go to some other folder and paste it. See, the pasting will not happen from original place. When you make a copy of it, the copy of the document will be placed in a temporary storage place, temporary memory. That is called Clipboard. How long it will be there? Up to some time only. Clipboard is not a permanent storage, correct? So when you paste it, it will actually paste from Clipboard. So you go to your smartphone and just select a contact and say copy. Your smartphone shows a message. Copy it to Clipboard. Copy it to Clipboard. Means the original place it is there. Contact, some storage is there. From the original place, it has copied into some temporary memory. From there, it will paste somewhere else when you choose paste command. Okay. Now, up to some time only it will be there, that copied one. Okay. Now, Clipboard is a debugging tool which contains a lot of data. So much of information will be there, which contains some data, okay, which contains, let's talk about with respect to work object, which contains information about work object, means property names and values. Property names and values contains on its page by name py work page. What is the name of the page? So I am now telling you Clipboard with respect to work object. This is applicable for everything. So Clipboard is a debugging tool which contains information about work object on its page by name py work page. I'll tell you what does it mean. Now you go here, create one work object. I already have created a few minutes back, right? I did not submit those things, I believe. This is test flow related. Okay, whatever it is, no. Oh, this is not this one. I'll just go with another one. Regular flow related work object, no? Okay, this is completed. Okay, this one. So here is the work object created. Now I am going to enter some data here. Okay, I'm going to enter some data here. Date of birth, something, age 23, gender male, email address, bhagat@gmail.com, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers I have entered simply and submitted. Definitely, you know that this data is stored into work table in PZ stream column blob format, which we cannot see. But as a developer, suppose if I open a work object, I closed it. Now I am going to open the work object. If I open a work object in PRPC environment, here I should design something to display the data. Suppose if I do not design here, as of now I did not design, then where can you see the details of the work object? Backend you cannot see anyhow, right? Now at the very bottom of your PRPC, able to see here, everyone, there's a word called clipboard. Keep the work object open, work object tab open here, keep it open, and then go to clipboard. You see something called thread. See something called thread. That work object number you will find out. Work object. Suppose if I do not open the work object and go to clipboard, I do not see that work object number in the thread. Means clipboard contains the information about an object as long as it is open in Pega environment. You open in Pega environment, then go to clipboard. In the threads, you have many threads, out of which thread you focus on? C-1009. Blindly, you follow this. Scroll down. You try to find out a page by name PY work page. Is there? So on the page, PY work page, you have age 23, date of birth so-and-so, email address so-and-so, Bhagat, gender, first name, last name, all these phone number, alphabetically ordered here. Here, what is the order? Alphabetical order. In this, you will also find some other properties. You see, PX OBJ class is also one property. So what is the instance class of this work object you want to know? HDFC vehicle work, that is being held by a property PX OBJ class. And if you want to know what is the work object ID, don't bother about this property. Focus on another property, which is important. This is the property. PYID. And do you have PX create date time, update date time, create operator, update operator, PX commit date time, PX create date time, PX create operator. Okay. Similarly, PX update date time, PX update operator, all these are available or not? Every column in work table will be available here as a property. In Pega, this is the naming convention. Column names in the table will be available in PRPC as properties. So PYID, right? Where is PYID? I will click on PYID. Where is it? I will click on PYID here. It will open. This property will open in Pega. PYID is an OTP property in work-cover class. Work-cover class. Pega stores work object ID value in a work table in a column PYID. But before it stores there, it needs to hold that value in the business logic. UI, business logic, database. So in the first from UI, if it is created, it should go to business logic, no? To store. When you execute the flow, look at here now. I'll go here to the flow. When you execute the flow, work object is created, generated, ID is generated. No? Generated ID will go into business logic. From business logic, it will go into table. So in a business logic, we need a property to store the work object ID value. For some time, it has to hold. No? Table, we have a column PYID. So the property name also PYID. So you can blindly remember this point forever. Okay. In Pega, the name, column names of table are exactly same as the properties of its environment. It's a environment. Property names and column names are always same. That's how Pega is generically designed. Okay. Now here you go. If you go here, so PX create date time, update date time, everything is there. PX OBJ class, all those are there. Now, clipboard is holding the data. How far it can hold, how long it can hold, I'm sorry. How long it can hold? It can hold as long as the work object is open here. If I close the work object, can it hold the data? Can you find it on thread of a clipboard? No. So that's what. What next is, clipboard holds the data. You remember one thing. Data means a property name and value. At runtime, a property name and the value it is holding together is called data onto its pages. Clipboard holds data onto its data means property, names and values onto its pages. Onto its clipboard holds the data onto its pages. Okay. So clipboard doesn't contain the data on itself. On top of clipboard, you'll find n number of pages. Go here. So go to clipboard. So many pages are there. So many pages are there. So there are different categories. Again, pages are categorized. These are categories. Inside each category, page 1, page 2, page 3, like this you'll find. So clipboard mainly has four categories of. Clipboard has 4 predefined categories of pages. Those are first one, user pages. Second one, data pages. Third one, linked pages. Fourth one, what is the fourth one? System pages. We will discuss about all of these things as we proceed further. But PY work page will be available under user pages category. So the page which holds work object data is a PY work page. So always remember. So the work, okay. The page which holds work object data is PY work page. PY work page. I will open one diagram and show you. Just give me 1 minute. So I'll go to diagrams once again. Clipboard. What is the diagram about? Clipboard. Where is it? Somewhere it should be available. Clipboard basic diagram. So I'll open here. Look at here now. This is PRPC environment. This is PRPC environment. This is backend table. In between Pega environment and backend table, there is something else. What is it? Clipboard. What is this one? Clipboard is there. I have written at the bottom. Okay. Here, clipboard is there. Now, from Pega environment, data will first go to clipboard. From clipboard, it will be taken into table. From clipboard, it will be taken into table. So reverse also see. Suppose if already something is there in table, you want to open and see in Pega environment, it will be brought from table to clipboard first. Then from clipboard, it will be shown in UI. From clipboard, it will be shown in UI. This is the architecture. Clipboard is an intermediate temporary storage place between PRPC environment and the rule-based tables. So another way we can say, clipboard is a debugging tool, technical definition. So this way also we can say, clipboard is a temporary, an intermediate temporary storage place between PRPC UI and its rule-based tables. Data will travel from forward to backward, backward to forward, front end to back end to front end. Like this, like that, data will transfer. Okay, travel. Every one of you, are you clear about clipboard? As of now, I just told you the basic things about clipboard. So it is just like clipboard will have data in the form of pages. See, suppose if you take a notice board is there. In a college, there is a notice board. Imagine that we are going to write a notice on A4 size paper, and that paper we are going to pin it on notice board. How many papers we can pin on notice board? Multiple papers. Multiple papers means each paper contains some details. So each paper is 1 page. On what? Notice board. Same way, clipboard contains data about something on its page. Like that, n number of pages can be there. Again, these pages are categorized. Work object data will be available always on PY work page, which is available under the category user pages on clipboard. User pages on clipboard. Clear? Makes sense, everyone? Now you need to remember these terminologies like work table, sorry, work class. Work class group is also work class. We call it as work class in short. So the terminology is class group. You will call it as work class. You will also call it as work class. You will also call it as transaction class. You can also call it as instance class of work objects, like that. You can say anything, but this is the most widely being used terminology. And in short, people will call as work class. So work class will have work objects. Work class is going to have work objects. Work object data will be available on work page. Py work page, you can simply say work page. Work page data will store into table, work table. Work class, work object, work class, work object, work page, work table. These are the terminology. These are correct. Work class will have work objects. Work objects will have its data on work page. Work page will have its data stored into work table. So data which you enter in PRPC environment will go to Clipboard. From Clipboard, it will be taken into tables. So tomorrow I'll explain you about the remaining. Are you clear, every one of you? So much of information provided to you. But if you look at a summary of this, the summary is very simple. Okay, the architecture of Pega is like anything you create in PRPC is an instance of some concrete class which stores into backend table. That's a fundamental architecture. Okay, every rule in Pega storing into some table, it is instance of some concrete class. That's the only point we focused on. Work object is instance of class. And next what we focused on, Clipboard. Clipboard contains data on its pages temporarily for some time. Okay, and Clipboard will have categories: user pages, data pages, linked property pages, and system pages. Our work object data will be available on a page called Py work page, which comes under the category always, which is user pages category. Make sense? I will attach these documents and diagrams. Diagrams related to Clipboard. Diagram related to what? Clipboard one diagram and class table mapping. Class table mapping diagram. Okay, I will share those diagrams along with the notes which I have drafted today. So you need to go through this. Those who understands this fundamental architecture can work as LSA, can work as an LSA. So architecture level you are learning. Pega class, March 9, 2025. I will share it. Okay. So we will update you about the interviews that you can start giving the mock interviews. We'll update you today. You'll receive in the group. Look at the messages in group when there is a new message. Definitely that is important message you see in the group. So group will not be open as of now. If you have any doubts, any questions, contact the mentor. So we will post the mentor number also in group. Have Ultra Viewer or something installed. Okay, then you can share the screen. Before you contact the mentor, just go to documents, try to revise the document to see where you have made mistake or something, and then revise through the video. If you're not able to get after revising through document, practical document and video, then you contact the mentor. Mentor is able to solve issue. Mentor is not solving, then WhatsApp me with the screenshots and explanation about what is the issue you are getting, what are you exactly doing, what is your development, and what is the error message, then I'll be able to help you. So I'm going to attach the documents now. I'm sorry, not this batch. 625 notes. Oh, only class notes, right? And diagrams. Yeah, you can wind up for today. I'm going to close the meeting. Thank you for joining, everyone.
Harsha, I have a doubt. In the PY work page, I saw like some properties started with PX and some from PY.
Other than something which I have told you, don't think about anything beyond. I'll explain you that property prefixes in the future classes. Okay?
Okay. Yeah.
Okay,
Thank you.
good.